The stream is streaming. What did I miss? I today was pretty exciting. I was working on the Roblox file decoder. I was like, Euster is bad. I can do better. Like, ew, ew, ew. And then I made a library. It's 900 lines of code. I had a pretty nice demo with 150 lines of code. But yeah, that's the way it is. And so I'm like, And then I'm like comparing and contrasting methods I think would be better than Euster. And this was a while back. A week ago. Okay. And then I made a library. I made it. I just like made a replacement for the library they're using. That's better. And then I'm going in to the library and implementing it everywhere. And we'll see what they think, because it's a massive, massive sweeping change. But yeah, I just thought I could do better. Like, it's I don't like that you have to construct all of the Eusters at runtime. Like, why not hash it ahead of time? Are there any runtime benefits, or is it just a matter? Oh, it's going to be like better performance, or hopefully, I guess. I just ran a bunch of benchmarks, and like, it's definitely worse, which is very, very expected, because my library is worse than Euster for a global string cache. For a local string cache, it's faster. For a pre-calculated string cache, it's over twice as fast. So we're not there yet. That's part 4, and it's the biggest part. But today I realized that I don't actually need the cache for either the reflection data or, well, I guess the util here as well. Targeted improvements. So it all comes down to Roblox files being dumb. The format is dumb, but like it makes sense. So like, the problem is that properties are serialized as strings. Every single property on every single object is the full string of the property name, which is stupid for a binary file format. But what are you going to use? Ints? Yeah. Anyways, properties. So then when you're reading the file, what happens? Well, you need to store the property somewhere. So you allocate a new string and put it into a hash table. Allocate a string, put it in a hash table. Allocate a string, put it in a hash table. Now you have 100,000 instances, all with duplicate strings in the property hash tables for each instance. So what if we deduplicated the properties across the entire thing? And that's Euster. It's a global deduplication string cache. So any string you send in that function, where's the function? What the function? It's gonna be, yeah, okay. So any string you send into this function gets memory leaked and deduplicated. So if it already exists, it gives you a reference to the memory leak, and if it does not exist yet, it makes a new memory leak. Are you seeing what I don't like about it? So this one, no. It does it at compile time. So mine calculates the hash ahead of time instead of needing to do it at runtime. So now we have a compile time reference that's automatically deduplicated by the compiler. I didn't have to do any special fancy stuff to like make sure it's all deduplicated. That does the stuff. So it's already hashed. There's no runtime cost for indexing by this object. In fact, it's faster because it uses the pre-calculated hash, which like that's the point of the uster as well. But if you start with a string, you always have to make a uster. So either you make a big chongus and like calculate your usters once and then like pass your chongus around to do your usters, or I don't know, you're basically out of luck. You always have to pay the cost. Whereas with my guy, you do it ahead of time. And it's just as convenient, right? And then, so uster has 64 caches that have their own mutex locks. And so based on the hash, it like goes into that bucket, locks it, and caches it or fetches if it's already there. And like, that's wild. My thing is simple. I studied Euster, so it has this bump allocator. All the bump allocator does is it goes like, boop. That's it. So it's just a linear piece of memory. And when you say, I want 5 bytes, it goes 5 bytes. I want 17 bytes, 17 bytes. It doesn't like plan ahead or do anything fancy. It just next, bump, bump, bump. So it's very simple. And there's a pre-existing library that's very fast for this. So that's the host. It's hosting the values. But this doesn't care if there's already a duplicate. So then my other type here is the cache. And that is the deduplication effect. So how do you use it? Let's go to the README on the guy. So how do you use it? So you have your host, storage, and your cache. So you call cache intern with host stir. So it checks the cache to see if that value already exists. If it doesn't exist, it allocates a new one. Already thousands of downloads? Yeah, it's just bots. People using the public code to test their like Rust forks and whatnot. My Rust fork is better. That's probably a very niche use case, but the official project also does that a lot. Okay, so that's in string internment. So you have a cache and you have your storage. So you can like intermingle as many caches and storages as you want. And then when you drop the storage, the memory is reclaimed. And there's no locking because it's all just Rust with like exclusive references and shared references with like immutable and mutable references. So this is like, this is the allocator. So this is a shared reference, but it does do interior mutation, but that's okay because it doesn't mutate any of the existing data because it's just bumping and bumping and bumping and bumping. So references to the existing data still remain valid even though you're mutating the allocator. That's the idea. And then so we've got a static one, calculate a compile time. You can make a boxed hash stir at runtime, calculate the hash, throw it in a box, and use it the same way because it's the same type, but like you manage it now. So you're responsible for the lifetime. Or you can use an interned one that is a reference to one of the hosts, and the cache tells you if it's already been there before. So we got lots of pieces to mix together in any way you want, right? So instead of like throwing the global cache, you can very explicitly use this cache and this storage and be explicit and drop it when it's done exactamundo. And so there's also this cool stuff. So the cache can also accept values that are not. So this sort of just deduplicates it, whereas this is allocating a new one if it doesn't already exist. So this function, notice it doesn't take a reference to the host. It's because it never allocates a new one. So it must outlive the value you pass has to outlive the cache, which is also true of the lifetime host. So this has to live longer than this. But then because I passed this one in here, this also has to outlive the cache. And so all of the intern values are the same. They're all deduplicated. They're all just bruh. So all the pointers are equal because it's passing you the one that you already have. And then you can also index a hash map using these and using the pre-calculated hash. Cool. It works with static, runtime, intern, all good. They're all the same type. And then we have this fancy fungus right here to whip up an unhashed stir. And it has to be this wacky, stupid class instead of just indexing it directly because of the weird trait bound on Rust's hash map. It's not quite optimal in my opinion, but that's the way it is. And so this is a string. It's just a stir, normal stir. But it's a new type that says I don't have a hash, and it can call the same function that usually gets the pre-calculated hash to calculate the hash on the fly. So it's like a convenience thing if you just want to chuck a string into the hash table and you don't care about like front loading the work of like calculating the hashes. So I would use this in my Lua script thing for the runtime scripts. So like if you have a Lua script and it just does like part.position part.position d part.position e part.position and it just like is generating new strings every time and trying to index the parts, my Roblox emulator would have to make a uster, and that is a memory leak for every new string. So this one doesn't do that. It doesn't do that, but you can still access the hash map. Time for the custom hash map crate. Well, actually, that's what this is using is hash brown, the raw hash table. That's why this looks so weird. This is neither a hash set nor a hash map, but it's basically a hash set. But like both of those are implemented differently. But then inside here, I'm calling find hash. So this is the internal hash brown hash map thing, and I provide the pre-calculated hash directly. You can't do this with the top level hash thing. With the same elegance. So like that's what this is for. The like hash brown internals thingy. That's what this is for. So cool. Okay, there's more cool things. Okay, so the library was using this like wrong cowster stuff in the database. So their idea was to like prevent allocation, but they didn't really know how to do it. And like I could fix that, but I just switched it to my thing instead. And so this is, they used Eusters in the instance properties, but they didn't use it in the instance property database. So there's like type conversion and stuff going on. So why not just serialize the database? It's a in-memory sequence of bytes that is deserialized and becomes the database object. Why not just use the same types? So you have your pre-calculated hashes and all possible properties that are known. So that's what this is it's refactoring the database to use the hash strs instead of the weird cowster things. But like strings, it's essentially strings. It's in this case, it's behaving the exact same way. They could have done it with a reference to a str and annotate with borrow, and that would have been zero copy. So speaking of zero copy, I serialized my own database. It's 50% bigger with the hashes. They're not deduplicated, but I could do that later. And I actually zero copy the hash strs out of the memory region that contains the serialized file of the database. When it deserializes it, it does visit borrowed bytes, and then this is a pointer to some bytes in the memory that represents the database that it's deserializing from, and then it just goes like, oh, those are bytes. Those look good. Use those bytes, and it just gives a static reference to the existing memory without allocating a new string, because there's a valid string in there somewhere. So it just says, oh, use that one. Zero copy. That's what they were going for with the cow thing, but they didn't get it. So I got it. So it just makes a hash str that points to the static memory that's part of the executable. And it's not deduplicated. We could make it do that, but we'll do that later. So many lifetimes. Yeah. It's going to get so much crazier tomorrow. Look at this. I'm annotating. I need to make everything there's three parts, right? So the first part was porting Euster to my library. And I'm just global. Chuck it away. Because I implemented the same thing as Euster, where there's a global cache. And then I'm just going to do it piecemeal, right? So the global cache, we're using my library now. And then after that, I introduce lifetimes to the objects, but I say use static. So all of them have lifetimes, but the lifetimes live forever. And then part 3 was the reflection database, refactoring it to use the hash strs internally. And then part 4 will be getting rid of all the static lifetimes. And we'll have explicit caches. We'll use the database hash strs. We'll have invalid files, a strict mode that rejects invalid files based on the properties and stuff. It's going to be so good. This is probably going to be a similar amount of work to what I've already done again. But I'm into it. I'm in it. It's very interesting. String internment. Library. Love it. And this is all because Roblox made a dumb file format. And how do you make it decode as fast as possible? String internment, of course. This is used in web browsers as well. String internment to reduce memory usage by deduplicating JavaScript strings and stuff. It's one of the reasons why it's so slow. If they use my library, it'd be faster.